Classification and study of fossils. Similar to the classification of living organisms, fossils are categorized into broad groups known as kingdoms. During the 19th century, fossils were primarily classified into two main groups, plants and animals. However, further research and discoveries necessitated the establishment of additional main fossil groups, including fungi and bacteria. By 1963, fossils were classified into 5 distinct kingdoms. Animalia. This group includes fossils from the animal kingdom, with the oldest known specimens dating back 600 million years. Planta. Fossils from the plant kingdom fall under this group, with the oldest specimens dating back 500 million years. Monera. This group includes fossils of bacteria without a nucleus, with the oldest known specimens dating back 3.9 billion years. Protoctista. This kingdom comprises fossils of single-celled organisms, with the oldest specimens dating back 1.7 billion years. Fungi. This group includes fossils of multi-celled organisms, with the oldest known specimens dating back 550 million years. Geological periods and paleontology. The late 18th and early 19th centuries saw the acquisition of basic information about the Earth's crust, particularly during the construction of railways and tunnels. William Smith, a British tunnel builder, noticed similar rocks along the North Sea coast and in Somerset dating back to the Jurassic period, 206 to 144 million years ago. Using rock and fossil specimens from various locations, Smith created the first geological surface map of England and also drew underground geological maps for certain regions, greatly advancing modern geology and helping to determine the Earth's geological timeline. Fossils played a crucial role in this process. The geological timeline from the Precambrian to the Quaternary period was developed using fossil bed data, which is still in use today. By examining rock structures, scientists identified the Earth's stages over different periods, and fossils provided information about the organisms that existed during those times. This combination of data led to a chronology, dividing the Earth's history into 2 eons, further subdivided into eras and periods. The Precambrian Eon, 4.6 billion to 543 million years ago. The Precambrian is the oldest and longest period in Earth's history, subdivided into various eons and eras. It includes Hadean Eon, 4.6 to 3.8 billion years ago. The Earth's crust was still forming. Archean Eon, 3.8 to 2.5 billion years ago. Early life forms began to appear. Proterozoic Eon, 2.5 billion to 543 million years ago. Single and multi-celled organisms existed. The Phanerozoic Eon, 543 million years to the present. Meaning visible or known life. The Phanerozoic Eon is divided into 3 eras. Paleozoic Era, 543 to 251 million years ago. This era, lasting 300 million years, saw a generally humid and temperate climate. Though ice ages did occur, the Cambrian period within this era is notable for the Cambrian explosion, a sudden appearance of diverse life forms. Mesozoic Era, 248 to 65 million years ago. This era includes the Triassic, Jurassic, and Cretaceous periods. Dinosaurs thrived and became extinct during this time. Notable life forms from this era include the horseshoe crab and the coelacanth, both of which have remained unchanged over millions of years. Cenozoic Era, 65 million years ago to the present. This era, currently ongoing, began with the extinction of the dinosaurs, recently divided into the Paleogene, Neogene, and Quaternary periods. The Cenozoic fossil record shows that species have largely remained unchanged, further challenging the theory of evolution. The Cambrian explosion. The Cambrian period, 543 to 490 million years ago, is known for the sudden appearance of diverse life forms, described as the Cambrian explosion. This phenomenon, considered one of the most remarkable events in the history of life, contradicts the theory of evolution, which predicts a gradual development of complex structures, Ordovician to Permian periods. Subsequent periods saw significant developments and extinctions. Ordovician period, 490 to 443 million years ago. Marine invertebrates and some terrestrial plants thrive, though ice ages caused extinctions. Silurian period, 443 to 417 million years ago. Rising temperatures led to the emergence of land plants, echinoderms, arthropods, and various fish species. Devonian period, 417 to 354 million years ago. Known for a mass disappearance of certain species, the Devonian also saw the existence of fish similar to modern species. Carboniferous period, 354 to 290 million years ago. Also called the Coal Age, this period witnessed significant geological changes and the existence of marine and terrestrial life forms like the coelacanth, a living fossil. Permian period, 290 to 248 million years ago. Marked by a mass extinction, some life forms from this period, such as dragonflies and spiders, have survived unchanged. Mesozoic era. The Mesozoic era includes Triassic period, 248 to 206 million years ago. Diverse marine and terrestrial life forms existed, but no intermediate fossils supporting evolution have been found. Jurassic period, 206 to 144 million years ago. Known for dinosaurs, the fossil record also includes unchanged species like early crocodiles and tuatara lizards. Cretaceous period, 146 to 65 million years ago. The extinction of dinosaurs occurred, but many aquatic animals and plants survived unchanged. Cenozoic era. The Cenozoic era, which we are currently in, has been reclassified into three periods: Paleogene period, Neogene period, Quaternary period. Fossils from this era continue to challenge the theory of evolution, showing that species have remained unchanged over millions of years, reinforcing the idea of a creation by a higher power. In summary, the fossil record provides significant evidence against the theory of evolution, showing that species have appeared suddenly and remained unchanged, supporting the concept of creation.